also define what it means to be in series and parallel for a circuit element. So let's start with our learning goals. Our learning goals are to understand and be able to apply Kirchhoff's voltage law to an electrical circuit, to understand the definitions of series and parallel for circuit elements, and number 3, to understand and be able to apply Kirchhoff's current law for an electrical circuit. Alright, so let's begin with Kirchhoff's voltage law. So I'm just going to write it as KVL. That says the voltage drop around a closed loop is 0. So what that means is if you start and stop at the same point but go in a loop, that the net voltage drop will be 0. So let's do a simple example. So let's have a voltage source connected to a resistor. This has a voltage V across it, resistor R right there. So if we now, and let's say this is the positive side, negative side, there's going to be a current I this way, and let's now go around and do the voltage drops. So we can pick this point right here to start. So as we go along with the current, we go from high voltage to low voltage across the resistor. So we're going to get a positive VR because we did a voltage drop. We went from high potential to the low potential. And now when we start to finish the loop, we're going to go from the low potential to the high potential. So that's going to be a negative drop across the battery. So this is VR minus V equal to 0. And this is Kirchhoff's voltage law. So we can redraw this as sort of an altitude type thing. So if we have our ground right here, this is V equals 0, and then this comes up to a height that corresponds to V. What happens as we go across the resistor, we drop down in voltage to the bottom potential. So this is now V sub R, and this is what our loop would look like. We're starting up here, going down in voltage, and then once we get to the voltage source, we come back up. So our net change in height is 0, so that's exactly what we wanted. Alright, let's go on to a little bit more complicated example. So if we instead have still a voltage source, and we're going to have 2 resistors. So this is going to be V, this is going to be R1, this is going to be R2. If we do and I forgot to write down that we're going to have current I flowing through the circuit. If we start up here and do a loop, come around, back. So the first part is V sub R1 plus V sub R2 minus V equal to 0, or the voltage from the voltage source equals the voltage across the resistor 1 plus the voltage across resistor 2. Schematically, in a little altitude type picture, we'll have this be our ground, so V equals 0. We're going to come up to some height V. Now the voltage drop across the first resistor is V sub R1, and then the voltage drop off across the second resistor is V sub R2. And if we do a loop, we see that we start up here, high voltage, we go 1 voltage drop, 2 voltage drop, we're now down